All right, here is video number 1, probably your 5 or 6 that are going to talk about your final exam topics and some things that you should be able to do on there. Okay, so these are the topics, of course. Right triangles, a whole lot of trigonometry, and some graphing. Right down here, there's some linear motion and angular speed and unit conversion, right? That kind of fun stuff. Once again, angle formulas, law of sines and cosines, and then some vectors and some polars, right? Not a whole lot of that. We spent the majority of the year on trig. So that's where we're going to start here also. Okay, so right triangle trig. If we have a right triangle, right, you have one angle as the reference angle. So this is your reference angle, probably called theta. There are, of course, 3 sides that go along with every triangle, or rather with every angle. The hypotenuse is, of course, the one opposite the 90-degree side. For a right triangle, that's the longest side. The adjacent side is the side that makes up your angle with your hypotenuse. And the opposite side is the one across from your angle. Okay, and from those 3 sides, we have 3 different trig ratios. We have the sine ratio, we have the cosine ratio, and of course, we have the tangent ratio, which all relate to specific sides of your triangle. So the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tan is the opposite over the adjacent. Okay, so those are your 6 or your 3 basic trig functions. And then we talked about your 3 reciprocals. So we had the cosecant function, which was the reciprocal of the sine. We had the secant function, which was the reciprocal of the cosine. And we, of course, had the cotan function, which was the reciprocal of the tan. So hypotenuse over opposite, hypotenuse over adjacent, and adjacent over opposite for your 3 trig reciprocals. So let's say that potentially we have a point at 5 comma minus 12. Okay, so 5 comma minus 12 is the point we have on your xy axis. So we go 5 to the right and 12 down, right, because minus is a 12. And there we have that point. So we can draw our triangle by going from the origin to that point and then back up to your x-axis, right? That is critical that you always make a triangle with the x-axis because this is the angle that we're talking about. So when we use the Pythagorean theorem with 5 minus and 12, we get a hypotenuse of 13 because negative 12 squared is 144. Okay, whenever we square a negative, we get that. So we could ask you, what is the cosecant of this angle? The cosecant is the hypotenuse over the opposite side. So negative 13/12, or 13 over negative 12. Okay, so from your triangle, right, we write down the correct ratio, and that's how we do these trig ratio problems. You need to know what the ratios are for any given problem. Okay, so speaking of angles, what if I gave you an angle of pi over 6? Okay, hopefully you know that pi over 6 is 30 degrees. Hopefully you know that. Okay, so pi over 6 is this angle that's formed with the positive x-axis, pi over 6. Okay, now there's some words that you might not recognize, hopefully you do, something called coterminal. Coterminal. Okay, so if a flight is coming to San Diego from San Francisco and a flight is headed to San Diego from San Antonio, San Diego would be the coterminal. Both of them are landing at that same airport. So let's talk about some angles that are coterminal. What if we went all the way around our circle, okay, and then ended up at that same point? That would be a coterminal angle. That one, in fact, would be 13 pi over 6. So 13 pi over 6 and 6 pi over 6 are coterminal, aka I just added 2 pi to my given angle. Okay, adding 2 pi to my given angle gives me a coterminal angle. And the other one would be, what if I went the negative way around my circle? What if I turned this direction? What would I end up at? Well, that would be 11 pi over 6. In other words, I would subtract 2 pi from my given angle. So I can find any coterminal angles by adding to my given angle and by subtracting from my given angle. So these two are my coterminal angles. Sorry, this one is negative 11 pi over 6 and positive 13 pi over 6. Okay, coterminal means ending at the same place. Okay, so there's some radians to degrees. Now, unit circle. Hopefully you know how to make the first quadrant of your unit circle. If not, this is how you make your first quadrant of your unit circle. Remember, we have 3 points. We have the pi over 6. We have the pi over 4. And we have the pi over 3. Okay, this is 30 degrees, and this is 45 degrees, and this is 60 degrees. So there were coordinates for each of these points, coordinates for each of the points. The first point had a coordinate of 1/2, comma, root 3 over 2. Sorry, it's actually root 3 over 2, comma, 1/2. Whoops, my brain. Root 3 over 2, comma, 1/2. And then this one was root 2 over 2 for both of them. All the pi over 4s have the same coordinate. And then up here at 60, this is where it was 1/2 and root 3 over 2. And then, of course, pi over 2 was 0, comma, 1. So 0 in the x, 1 in the y, and our point here was 1, comma, 0. Okay, so it turns out that the x value, right, this x answer is always the answer to your cosine question. And the y value is always the answer to a sine question. So the sine at pi over 6 is 1/2, and the cosine at pi over 6 is root 3 over 2. And then we came and we ran into the tangent. Well, the tan was the hard one because that was the y over the x. Okay, so you can calculate the tan every single time. So like the tangent at pi over 6 would be 1/2 over root 3 over 2, which simplifies to 1 over root 3, which further simplifies to root 3 over 3. Okay, so you can always calculate the tangent if you know the x and the y. Okay, well, I think that'll be good for this video. There's some quick things about trigonometry. Hopefully this has helped your brain become a little bit better at trig. Okay, bye.